Okay, I am now going to go over the last exam. I believe everybody has taken. I'm going to go ahead and close it out. And that way I'll make it available for all. All right, here we go. For exam 3, make sure you feel very, very comfortable. Exam 4, make sure you feel very comfortable with the tables in the back of the book. And what I'm talking about is the ones that are located, talking about the Z tables, the F, and the T as in Tom. All right. So if I come back out here, looking for exam, go to my account. We're going to go here. I want exam 3 or 4. Let's see. What was 4 here? All right. So this one was basically just a repeat of section 5, and it's giving you the ideas of how to deal with probability and the normal distribution table. All right, a class consists of 10 males, 30 females. Most of you got this one right. If one student is randomly selected, it's always going to be the number of potential choices on the denominator. So here we have 40 will be our denominator, so you can scratch out C and D. And if it's asking you a male student, there are only 10 males in there, so it's going to be 10 over 40. Right? Or a 1 in 4 chance you'll pick a male randomly. Now, does it mean you're definitely going to pick a male? Absolutely not. Or, it just means that there is a 1 in 4 chance you'll pick a male. Right? Which of the following accurately describes a portion of the tails of the normal distribution? Right? First of all, what is the normal distribution? Right? Normal distribution curve. You get back over to your book here. Right? This is it. This is in theory only, which makes it really hard to understand. So it's basically just taking some information, and somebody noticed that if they were to sample an entire population, they found out that on average, if everybody is 5 feet tall, right, that they can convert these scores into what we call z-scores, so we can make comparisons. The only reason we convert scores into z-scores is it makes it easy to know what's going on. Think about it, it gives us distance and direction. And what I mean by that is if you tell me you made an 80 on an exam, I don't know if that's a good score or a bad score. If somebody tells me they did 23 on an ACT or 750 on SAT, I don't know what that means, right? I have to know what's the average score. And that's what the z-score enables us to do. So you'll have your raw scores. You can convert them into z-scores. And what's nice about that is when you convert them into z-scores, you have this table here, which can tell me how likely you are to find certain information, right? And that certain information is what we talk about. This curve here underneath it is basically 100%, right? So when remember when you're in school, when you hear somebody scored in the 10th percentile, the 90th percentile, what does that mean, right? If you score in the 10th percentile, or like children, like when you go to get them measured and weighed, they tell you they're in the 10th percentile, 25th percentile. That number there, the 10th, the 20, and the 90, if they're in the 10th percentile, that means that they are below the average here, and there's only 10, they're taller than the 10% there. So 90% of the children are taller than them, but they are right here at the 10th percentile. If they score at the 90th percentile, let's say in weight, that means that 90% of the kids are way less than they do, and only 10% weigh more, right? So that's what we're going to be doing in here. Or like we did on the discussion board, try to figure out what percentage of the population would likely fall between your height and maybe 1 standard deviation above. Now, when we get that number, that probability, 20% or 30%, whatever it is, does it mean that I'm going to definitely find 20% of the people I'd ask are between my height and the standard deviation above? The answer is no. It just means that it's very likely, right? Depending on whatever the alpha is. All right, so now that I'm giving that spiel, and definitely make sure you're reading your book so that you understand these concepts. Get back to the exam. All right, so which of the following accurately describes the proportions in the trails of the normal distribution? right? Proportions in both tails are always, always going to be positive. In fact, everything under the normal distribution curve is a positive number. Nothing under here is negative. When we're talking about probability, there are no such things as negative probability, right? A probability, if something is unlikely to happen, the probability is very low. If something is impossible to happen, like pigs fly, the probability is 0, right? There's no such thing as a negative probability. A z-score can be negative, right? Because that just lets me know, talking about the averages. So make sure you kind of understand the difference between a z-score and a probability. Right, number 3, which of the following accurately describes the proportion in the body of normal distribution? All right. The way the normal distribution curve is done is right down the middle here. If we said everything underneath it was 100, that means right down the middle, 1/2 is 50, the other half is 50. And notice, if I were to fold this on top of each other, it's perfectly symmetric, right? That's why we call it a normal distribution. The book didn't spend a lot of time talking about distributions that are not normal, right? But let's just say we had a population with, well, like our classroom, for example. Our classroom may not be a normal classroom, a normal distribution, because if you notice, we don't have any men. And on average, we would not say that 100% of all classes at UNCP are 100% women. That just happens to be what ours is. So our class is not a normal distribution. All right. But if I were to go and check in with every single class at UNCP, I bet you I'd probably find a 50-50 ratio, because in the real world, 50% of people are men and 50% are women. So the answer here is going to be C. Body proportions on either side of the z-score are greater than 0.5. All right. The reason it is not D is because if it's less than 0.5, that means I don't have exactly 100% underneath there. On the right side of the z-score are less than 0.5, and on the left side are greater than 0.5. Can't happen. They are symmetrical, so they have to be the same, and they have to total to 100. So we go with either side of the z-score are greater than 0.5. In fact, they're like 0.555, whatever. All right, number 4. What proportion of a normal distribution is located in the tail beyond z equals 1, right? I can't give you any information about that here, right? But I do know this. I know that a z-score of -1 would be, let me duplicate this. All right, I'm gonna make this a little smaller. Okay. So it's asking me here something -1 standard deviations below. Right, so let's say this is 1 standard deviation below the mean, right? And this being the mean. What proportion of a normal distribution is located in the tail? So it's basically asking me everything to the left of that point. And what I'm talking about when I'm doing these, I like to have all these little diagrams in here. It's asking this area from here to here, right? And if I know that this is 1 standard deviation below the mean, I have to have the tables to answer this. The tables, like I said, are in the back of the book. Right? So it's asking me basically in the C column here, what is at the -1? So if I go to the table, I can enlarge the view here. I'm looking for the Z to be 1. I come all the way down. And just FYI, if you're not using this table, make sure all the tables are going to be read differently. Sometimes they'll have 2 columns, sometimes they'll have 1. Sometimes they'll only tell you just this distance in here. But if you have that, you can figure out this and this, right? And because we know that this whole right side right here, that's 0.5. So if I wanted to know 1 standard deviation below, basically asking me here, if I come over here, it's asking me that C column, which is going to be the 0.1587. If with a z-score equal to -1, the proportion of people, or the percentage of people that are to the left of the -1 is going to be 15.87%, or a probability of 0.1587. The answer here is going to be C, 0.5817. All right. The reason it is not a negative score, right, is because, like we said earlier, the probability, or the area underneath, is 100%. All right, so it can't be a negative probability. So when you see this 0.1587, 0.22, those are all probabilities. When you see the z-scores, those can be negative. Right, a vertical line drawn through a normal distribution, 0.5, separates the distribution into two sections, the body and the tail. What proportion of the distribution is in the body? So here, if I have a score of z equals 0.5, same thing we did before, I gotta go back to my tables, look up the 0.5, and then figure out what proportion of the distribution is in the body. So let me just use my tables. I like to look at it, I'm looking at it on my desk in the table first before I actually go to the table online. And so a z of 0.50 proportion in the body. And that just means to the right of it. So what it's basically asking me is, I'm going to move that out of here. I know I am 0.5 above. And it's asking me what proportion is in the body. When it's asking me about the body, it's basically asking me everything. Which I have a different one. If I could turn this around. Can I kind of, yep, everything, here we go, to the right, right? That would be considered the body, right? Now, I already know that half of this is 0.5, right? Just due to probability, not because the z-score is equal to 0.5. So I know if I am not quite an entire standard deviation above it, I know that my number can't be bigger than 0.5 because I'm only dealing with this half. So kind of scratch at that 0.6 and we call it here. So a vertical line of 0.5. I know that this piece here is 0.5. I know that that area from here to here, right, the B. So if I go back to my tables, that 0.5 goes back to the table. And the tables make it really super easy to read here. You come back up. You come over to 0.5. All right. And proportion in the body is going to be the 6915. So 69.15%, assuming that the z-score is equal to 0.5. So just barely over the top, all right? All right, where are we? All right, here, a vertical line is drawn through a normal distribution, z equals 0.8. What proportion of the distribution is on the right side of the line, right? So here it's just asking me what's on the right side of 0.80. I did the same thing. I'm going to go back. Let me just show you what it looks like. So here it's asking me exactly what's on the right side of the 0.80. I can go back to my tables, right? I'm looking for the z equal to 0.80. All right, and here I am looking for what is just on the right side, like what is in that tail there. That's going to be 0.2119, right? 0.2119. The answer is going to be D. D is in dog, right? What proportion of the initial level distribution between 1.25 and 1.25 plus and minus? Here, go to your z-score of 1.25. Right? And here, remember, I'm trying to find out what's between the two. So for me, the way I always like to use this D column here, and then I like to double it, but you could have done something completely different. So for me, the proportion between the mean and the Z, I know that from the mean of 0 to 1.25 is going to be 0.3944. If I take 0.3944 to go up 1.25 and then plus 3944 to go down, and what I'm talking about is this. I know that this area, all right, from there to there, I'm going to move this over a little bit. Let's assume this z-score here. Let's assume down here, put a little box down here and go 1.25. That's 1.25. That's our text box. All right, let's sort of 1.25. So this is the positive 1.25. I'm sort of drawing these out. And then I have the same thing, Control C, Control V. But this one is going to be to the left. And this is a negative 1.25. Negative 1.25, and that's my other Z. So if I know the distance from this one to this one is equal to, I would sort of like have this other arrow here. This right here, the distance between here and here. Right? And the reason I want you to get comfortable with this is because when you start doing the t-test, you're going to have areas that you're not going to include. And so you want to make really comfortable moving things around in here, right? So I know that the area between this 0 and plus 1.25 is equal to 0.3944. Right, this here is equal to 0.3944, and I have the same thing. If I had an arrow over here, this would say 0.3944. So if I add those two, or multiply by 2, I am going to get here 7888, right? 0.3922 times 2 is 0.7844, all right? So your answer is going to be C. All right, a vertical line is drawn in a normal distribution Z is equal to 120. What proportion of the distribution is on the left side of the line? All right, so go back, and this is why I want to see you start drawing these. Here, I'm asking me on the left. Vertical line is drawn at a normal distribution of Z equals 1.2. So let's get rid of this. I'm just going to sort of pull this over to the side because I don't need that right now. I'm going to keep these around. I know that this one is going to become a 1.2. Right, this is no longer 3.944 though. Right, so now I go to the actual book and I'm looking for the proportion of the left side of the line. So I'm looking for this area from here to here. All right, I'll just put this down here. All right, so what area is to the, oh, sorry, the left side of the line? All right, so we're actually going to go here. I'm looking for this. All right, so if I'm looking for this, I can figure out the distance from here to here and then add a 0.5 to it to cover the entire left side. Or I could figure out what's just between this one and to the right and then subtract that from 1. So there are lots of ways you can do it, whichever one makes most sense to you. Get comfortable with doing that, okay? So if I go back out here, I'm looking for 1.20, right? I'm looking for everything to the left of 1.20. So for me, I always like to figure out what's in the tail, and then I want to subtract from there. And so here, I'm going to go with 1.20. To the left of it is going to be what we call the body, and it's going to be 0.8859. You could have done it the other way. You could have taken 1.20, said, oh, I know the area, the probability between the 0 and the 1.2 is 0.3859. If you notice, and I could have added a 0.5. The difference between this column and this column is everything in here. When you add the other side of the equation, 0.5, you get that. The relationship between B and C is if you add these two together, you get the 100 or the 0.1. All right. Almost done. What is the probability of random selecting a z-score less than 1.25? All right, so probability of selecting a z-score that is less than 1.25. So now I'm looking for everything to the left of 1.25, all right? That one here is going to be 1.25, 0.8944 to the left, all right? And if you have any questions about these, let me know. Right, a normal distribution has mu equals 80 and sigma equals 10. What is the probability of random selecting a score greater than 90 from this distribution? All right, so this is sort of like that 90th percentile. You have two pieces of information. You have your mu and your standard deviation. So I just need to figure out what is my z-score. All right, so I want to know what's greater than 90. So if I take the formula here, all right, 90, my z is going to be equal to my 90 minus 80. Right, that's 10. 10 divided by 10 is equal to 1. So it's asking me basically a score greater than the 1 percentile. All right, so that is going to be, go over here, asking me from this distribution, what's the probability of getting something to the right of a z-score of 1? All right, here we go. And I'm looking for to the right of a z-score of 1 is going to be 0.1587. All right, so if you have any problems with any of these, let me know. If not, I was going to say go ahead and post any questions you have to the discussion board or give me a call at 337-371-5809, 337-371-5809. Thanks so much.